All right. I suppose I'll kick it off and hand it off to you, Don.
All
Thanks,
right.
everybody, for joining us for this webinar. We're really excited to tell you about the CP stage antenna, newly released this month. We're really excited about it. And Don Boomer, our senior applications engineer, has a nice walkthrough for us. If you have any questions, we will try to address those at the end, but feel free to submit those. Without further ado, Don, take it away.
Yeah. So not just a new antenna, but a problem solver. That's why we're doing this, right? So, so let's not talk about antennas for a minute. Let's talk about making your whole system work, right? You got to talk in one end, it's got to come out the other end, or the other way around if it's in-ear monitors. And that is dependent on all the pieces and the overall system performance. So, you can put expensive tires on an old beat up car, but you still got an old beat up car with expensive tires. You gotta look at your whole system and look at what's going on. So once you've bought your gear, you've hooked it all up, you have whatever potential you have. If it's a very expensive system, it probably has more potential than an inexpensive system, but whatever, you got that, that's where we're starting. Okay, so how do we keep that working? It basically comes down to these two things: the signal strength and the dynamic range, which with radios we call carrier to noise ratio, right? So these are the two things we have to watch, assuming your batteries didn't die and all that other kind of stuff, you didn't break a wire. This is what we got to watch to be essential. So the way we lose signal strength is obviously the distance. The farther your transmitter gets from the antenna, the receiving antenna in this case, the power just goes. As you walk away, it gets weaker. That's pretty straightforward. The other major reason is polarization losses. I didn't include not being in line of sight. So obviously you got to be in line of sight. But polarization losses, so that cuts the signal strength. Those two things: distance from transmitter to antenna and polarization losses. That's 99.9% of it all. Now, dynamic range is a different thing. And loss of dynamic range happens when you lose signal strength. It also happens depending on the amount of local interference that you have. DTV stations around you, obviously local interference from who knows what, from everything with a computer chip, LED lighting, other stuff, that's in your room. Hope you don't have an X-ray machine on stage, but there you go. And then intermodulation. And well, that's why we preach, please use a frequency coordination program. We got a free one on our website. Okay, so there's two things happening here. So if you're as old as me, you're used to things that look like this. If you're an old ham radio operator, which I am not, but they used to have a thing called a Q meter or a link quality.
Don, I believe the technical term for that is a boat anchor, correct?
Yeah, pretty much. Pretty
Yes.
much.
Okay.
We don't do this much anymore, but you can have a strong radio signal, but lousy audio. What good is that, right? You gotta have audio quality is ultimately what we're looking for. We don't care about any of the numbers. They are what they are. If we've got audio quality sufficient to proceed, then we're in good shape, right? So that's what we gotta worry about. So we're gonna talk mostly about in-ear monitors today. And in-ear monitors are almost all analog, which you kind of got to have because digital has some other problems with latency. There's one or two out there, but 98-9% of the market is analog systems. And also they're single-ended for the very most part. They have one antenna, they have one radio receiver, okay? So that's what we're dealing with. So if you've attended a few of these, you know that I always talk about having 20 dB of dynamic range. So depending on the quality of your gear, you don't really have to have 20 to make the radio connect, but you got to have 20 to sound better than a cassette deck, you know? So, especially with analog. Now with digital, this is different, but we don't really have any digital IEMs, and we probably won't really see a lot of this because of the latency issues, all right? So if the signal strength from your radio gets down into the 12s or lower, you get dropouts. The radio stops working. But as you climb a little bit above that, your radio works. It just sounds bad. It has noise, it has distortion, it has less frequency response, it has poorer dynamic range. In other words, who would want to stick this in their ear? It's crappy. We don't want it. So we got to get up to at about 20 is where you start getting good, you know, better than 50 dB dynamic range. And then if they've got companders, we can play with that number. But that's where the radio starts getting to be about that point. And obviously, we'd like it to be even better, because that'll ensure that during our performance, we're not going to have whistles and crunches and, you know, junk in our ears. Because really, it's much worse in IEMs than it is even with your wireless mics. With your wireless mics, you can drop a letter or two out of a word now and then, and it doesn't cause the end of the earth. But if that's in your ear and you're a musician and you're trying to perform, you can see the end of the earth from there. So that gets to be a tough situation, right? Okay, so this is what we got to do to maintain our audio quality. So we developed something to do that with that previously there hasn't really been. This is our new CP stage antenna as opposed to our CP beam. So let's talk about this for a minute with in-ears. Here's the front and the back. It's a very thin, you know, it's an inch or so thick. It's like 10 inches by 12 inches, and it's made to screw onto a mic stand. All right, this is primarily for portable work. You can install this. We've got other installation antennas, but this is mainly for people that are going to put this up on a mic stand, probably. You're not limited to that, but that's where most people are going to use this. So let's talk about this antenna for a minute. It has circular polarization. We're going to dive into that in a minute. It'll cover from 470 to 928 megahertz. So that's the there are in-ear monitors in that. That's the low ISM band. So it goes up to there, and that pretty much covers anything in the world. There are some other frequencies. I mean, you know, there's Wi-Fi and 5 gig, and we're not talking about that because there's really not much stuff there. Okay, this is a small, easy to move package. It's very lightweight. So if you're one of those bands that has your own IEM monitor mix fly pack that you take with you, this it isn't much of a chore to bring along. And this will outperform your traditional whips and paddles, and we'll show you that in just a second. There's one more feature about this. Guess what? We've now got an IP-rated antenna. So you can leave this one out in the rain. You know, so that's something new for us. There really are very few IP-rated antennas out in the world. So if you need a weatherized antenna, you can use this one for mics or ears. So you certainly can use it either way. Antennas always they're reciprocal. You can either transmit with them or receive with them, provided you don't have a little amplifier on board. That makes it only go one way. Okay, so how are we gonna improve audio quality with this circular polarized antenna? So we got to talk about polarization. And polarization just has to do with the pattern in which your transmit antenna transmits and the pattern within your receiving antenna receives pattern, probably not the right word, the way it responds to radio waves, right? So a radio wave has a electrical field and a magnetic field. Almost everything just pays attention to the electrical field, so we're just going to pay attention to that, right? So when your antenna is vertical, in this case, and your receiving antenna is vertical, you're going to get all the power that you can based on the quality of your gear, right? So here's a little demo. So that's a dipole antenna. That's a whip with a light bulb in the middle of it, right, between the two elements. And when the transmitting antenna is in the same direction and you key it, you light the light. But now if I turn it sideways, that antenna no longer sees enough energy to turn on the light. You can see it doesn't matter upside down, right side up. It only matters that they're in the same plane, right? So if everything's vertical, everything's horizontal, everything's 3 degrees, whatever it is, you get full power, right? So whips and paddles are linear antennas. Most everything is. Circular polarized antennas are, not the common thing, because they're more expensive, they're difficult to build, and this was an easy way to do it. All right, but now when we're talking about circular polarized antennas, what you get is an antenna that spins the pattern, right? So it's no longer fixed. At any given time, if we stop time, that antenna, well, this is moving slow. It's going at the speed of light, folks, so you're not going to be in between. It doesn't matter how you're twisted, you're always getting full signal from the antenna, right? So if we're talking about in-ear monitors, single-ended, and you put that on your belt and you put your paddle or your whip to transmit with, and it's vertical, and you're standing perfectly straight up, you're in great shape. You're going to get full power. Same thing is going to happen with a circular polarized antenna. Nothing exciting here. But as you start to turn, the receiving antenna's ability to grab the signal out of the air starts to fall, and you're constantly losing power, up and down and up and down and up and down. So if we went back to that first chart that I talked about, your audio quality is tracing that up and down movement, right? So your quality is getting better, getting worse, getting better, getting worse. And if you manage to turn all the way horizontal, if you lie flat on your back or you crowd surf, I had a church call me and they were having problems. Part of the pastor's presentation is he lies flat on his back on the stage. Why was it dying? This is why. You can't do that with linear antennas, right? Your direct signal could drop 20 dB. But it won't make any difference to a circular polarized antenna. So no matter how you prance around the stage, you turn, you twist, you bend, it doesn't matter to a circular polarized antenna, right? But to a linear antenna, it's always going up and down. And if your signal strength is going up and down, your dynamic range is going up and down with it. And if your dynamic range is going up and down, your audio quality is following your dynamic range, right? So that's the other part of this. Really what we're concerned with is the audio quality, because as long as we got enough signal, we got enough signal. And you're probably going to be better than this most of the time. But, and if you are, that's great. But if you fall below this, that's when you start getting junk. And so using a circular polarized antenna is greatly going to take care of that, right? So we remember this picture, right? So we want all the dynamic range we can get. The noise probably isn't changing in your room. The noise is what it is. But the signal strength is going to change depending on how far away you get. So that's another thing. If you walk far away, your audio quality is going to go down. And that's inevitable. Everybody can figure that out. You can keep walking and you'll get out of range eventually. But if you're basically on that stage, we got to keep this dynamic range up so that you have good quality sound. I would say this doesn't, digital is a different thing. and it's not really affected like this exactly, but we just don't have digital in-ear monitors because they're late. They delay time, and that's a big problem. Okay, I want to talk about the pattern and the range of this new CP stage antenna. Down on the bottom, that's our CP beam. That's the one we've been making for 10 years. It is a circular polarized antenna. It is a wonderful antenna when used properly. And if it has great distance that it'll cover. So I have to tell you, I struggled. The blue triangles are not exactly to shape. The bottom one should be a 70-degree, and the top one should be 120 degrees. There was just no way I could fit that on a page so you could see it. So pretend that's what you got. But really, antennas, if you look at the coverage area, it's about the same it's almost exactly the same for any antenna, right? You can make it, long and thin, or short and fat. It's the same amount of energy inside those triangles if you kind of break it out that way. But the way we focus the antenna is very much like a megaphone, right? So we can concentrate power in one area, or we can dilute power in one area. So this is not a good thing or a bad thing. This is a thing it's just like getting the right thing, right? So CP stage antenna, I put typical max 200 feet. I personally have used them way beyond that and through walls and got considerably farther than that. And there's no reason it can't go 400 feet or 600 feet under the right conditions. But whatever it does, the CP beam is going to do about triple of that. So if you got to get somebody a couple of football fields down, you definitely want to use a CP beam. But if what we're talking about is being on a stage, which is like where almost all the wireless mics get used, and that's not a big distance. A really big stage is 100 feet across. So we got lots of coverage for that. There's one other thing to think about here, and that's how close you can stand to this with your receiver, right? So pretty straightforward. If it was a PA speaker and it was, blasting out music that you could hear 200 feet away, you don't want your head 6 inches from it, right? It'll blow your head off. So if you're going to put your antennas on stage, you're going to be closer to your antenna. If you do that with a CP beam, it depends how much power you have and how much you have it set up and your cable lengths and all that. But you can get too close to one of these antennas. So with a CP stage antenna, 10 feet is probably fine for most people under most conditions. And if 10 feet was fine and you swapped it out for a CP beam, all of a sudden you need to be 25, 30 feet away. Sometimes that's difficult to do. You just don't have enough space to do that. So think about this when you're using it. Like I said before, the CP stage is really intended to be up on stage with you, right? If you're going to put it at the back of house, against the back wall, or you're going to put it at the front of house mixing position or something, then the CP beam might be the way to go. The CP stage might be the way to go. They may, in fact, it may not make any difference between the two, just depending on the size of your room. But so keep this in mind. You can get close to a CP stage. You cannot get close to a CP beam. Same way with a paddle. Actually, your paddle kind of falls in between this. A typical paddle, if let's just say that you could get 10 feet to a CP beam based on the way you've got everything set up, you'd have to be farther away than that with your paddle, right? You'd probably have to be 15 feet. So that's another thing to consider anyway when you're looking at this. And then, of course, if you're going to use this, you got more than one, you're going to need a combiner. And it just hooks up, the way it hooks up with combiners. This is our new Combine 6 HDR, which is a wonderful thing. We've talked about that on some other stuff, so I'm not going to go into that much, except to say that It's a half rack, and we've got a half rack distro, and if you're back to one of those fly packs, you now could do 5 mics and 6 ears in one rack space, so that's pretty cool. Anyway, all right, so moving on. So you can also use this antenna for wireless mics. Why would you want to do that, and where would you want to do that? So the first thing where it would be a good option would be if you have a really irregular shaped room. Nah, it could be any number of irregular shaped rooms, but it's pretty easy to think about an L, right? If I were to put 2 paddles down at the end of that room, and shoot them the long way into the room, in that main section of the room, I've got strong coverage, pardon me, and I've got diversity. But radio waves move in straight lines, so in order for them to get down into that L shape, they have to bounce off something like balls on a pool table. And they'll get there, but obviously you lose energy bouncing around and all that. So your coverage is not going to be very good down in there, and it's just going to depend exactly on where you are. Sometimes it'll work, sometimes it won't work, sometimes it almost works. There you go. So what people sometimes do is this. They'll put one antenna shooting into each section of that room. Okay, that gets you coverage, but it doesn't get you diversity very well, right? So the diversity works the best when you're getting equal power from each antenna, more or less. In other words, you can't have 90% of your power in one antenna and 10% in the other, because if it goes to switch over, it's really not going to find that weak antenna. So you got to have, enough signal in both antennas so that it can switch. But what's going to happen is as you get closer, to the east side the west side of that, closer out of that L, you're going to lose the second antenna in relationship, right? So people do this. They think about maybe a football field, and they go, well, if I put my antennas on both of the 30-yard lines, I'll cover the whole field. And the answer is, yeah, you probably will cover the whole field, but where you'll have diversity is in the middle of those 2 antennas. And as you get closer to the goal lines, when you get all the way down to a goal line, the opposite antenna is almost gone in power relationship. So that probably doesn't work well. Coverage, but not diversity. We want both. When you use circular polarized antennas, we don't really care about polarization. Which brings up the question, can I get away with only 1 antenna and not 2? And the answer to that is probably for most people, most of the time, yes. But I certainly, for the cost of 1 more antenna, certainly want my system to be extremely stable, more than super stable. So I'm using 2 antennas. But under some circumstances that might work. You could put the CP stage you could use, and then just put a whip on, so you got something on the other side in case it ever goes over. It really won't. But anyway. So if you've got something like this, or like for theater, you may have big set pieces. So sometimes I see people do this. Even on a stage, you got a rock band and they put an antenna on each side and point it across the stage. And it's an acceptable way to do it. It's probably not the best way to do it, unless you have things blocking, right? So if you were to consider looking at one antenna and looking at its pattern, and you send it out in a big V, you can see it's going to have shadows behind some of these set pieces. So when you put an antenna on the opposite side of the stage, you can kind of shoot it into those shadow spots. So this makes sense depending on what you've got in stage, what you've got on your stage. This might make sense in a casino where you got slot machines are 27 feet tall now with all the video stuff going up them. So you can get shadows behind that stuff. Or you got posts, in your room holding up the ceiling or something. So this could make sense if that's what you're doing. But We probably would still rather send you to using a DFIN or a de-architectural as opposed to doing it this way, like I said, unless you've got the blockage. So this is our new CP stage antenna. It is shipping. You can buy one today. And oh yeah, the good news is it's like less than half the price of anything else. This is by far the least expensive circular polarized antenna you can buy, probably by half. This is only slightly more than a paddle at this point. And the additional quality that you'll get in your in-ear monitor system is well worth it to me. I'm not having, lousy sound in my ears. Nobody wants that. You're just going to make everybody unhappy. So here it is. It's shipping. You can buy one today. Call us up, order one, or you can buy it from all the usual suspects. I believe it's in stock there at almost any of the places people buy stuff. So with that, I think I'll turn it over to any questions that we might have received there. I'm not really seeing them on my screen, but maybe you can see them there, Chris.
Yeah, thanks, Don. That was great. We have a few here. I answered a couple as we were going along. Folks looking for clarity on what is an IP rating. Ingress protection is what an IP rating is, and it's a way to categorize, a generally electrical or mechanical enclosures ingress protection from water or objects. So everything from your wristwatch to your, whatever outdoor based product will carry some kind of IP rating. And that helps ensure that, over time the enclosure is gonna hold up and it won't degrade and stop working on you. So that's a question that comes in all the time. IP ratings and outdoor antennas and the like. So that's a big driver of the CP stage industrial design. Let's see, Don. Distance between a diversity fin and a CP stage. So if you're running your CP stage for your IEM rig and you're running a D fin for your wireless mic rig, what's a good setup there?
100 miles apart works pretty good. So if we're talking about UHF wireless microphones, the 500s, the 600s, the 700s, if you're not in the United States, best practice would be to keep all of your antennas, if they're in that range, about 6 feet apart from each other. So if you're using two paddles, they need to be 6 feet apart from each other. If you then add a CP stage to that, it needs to be 6 feet apart from the closest paddle. Same way, if you're using a D-fin and a CP stage, they should be 6 feet apart. Now, they'll work closer than that, but the antennas interfere with each other, right? So if you get them closer together, you're throwing away performance. If you can afford to throw away performance, you're okay, right? As long as it's working. If you're above the threshold where you're working, you're working. But I'm not throwing away anything that I don't have to, especially if it doesn't cost me any money. I mean, just move the antenna. So I would say you should shoot for 6 feet. That's a good, safe number to use with any antennas, whips, paddles, D-fins, CP stages, everything. Antennas should be 6 feet apart.
Okay. Couple questions in here about gain, antenna gain, paddle gain relative to the CP stage. Helical antennas. Do you want to maybe just touch on that for a second, Don, where this kind of lands? Because a lot of different designs, a lot of different design choices in antennas made based around, directionality, right?
Right. So we covered that with the pattern. The
Right.
power is really the same. It's just where are you putting it, right? So, I could take what could I take? I could take something and put it in a cluster, and it's powerful in that cluster. I could spread it all out far apart from each other, and it's less powerful, but you still got the same amount of stuff, right? So, like I said, with this antenna, and so with in-ear monitors, let's go back to that. We are limited to 50 milliwatts if you don't have a license. That's a lot of power. They generally don't get run in professional applications at full power. Sometimes you got to power through, but the more power you use, the more interference you're making for everything else. So it's harder to do more power with more units, and that's mics and if you've got 8 mics and 8 ears, that's a whole different story than if you've got one mic and one ear. But like I said, the CP stage should be plenty. Well, I'll tell you my personal thing. Okay, personally, I was using Audio-Technica 3000 in-ear monitors set to 10 milliwatts, which is the lowest they'll go to. With this antenna, I forgot what I was doing, walked out of our rehearsal studio, walked out of the reception area beyond that, walked another, I don't know, 150 feet to the house and went in the house. So now through 3 walls and, 250 feet away, I accidentally left them in my ears. They were working fine, right? Depends where you are. I'm kind of out in the country. You probably wouldn't get that performance in the middle of Times Square, but that's what I mean. It always depends on where you are. But I would say for most people, I would expect the CP stage to do about 200 feet in front of it. If you need well more than that, like I said, if you want somebody on the other side of a football field, I would be using a CP beam. That's what it's built for. But if you're going to put your antennas up on stage, especially, bands that carry their own equipment, there's a lot of that now. And especially their own ears. Like everybody, you use the house PA, but you carry your own ears, and it just cuts down on, setup time and sound checks and all that stuff. It's such an easy way to operate. And you get the same thing night after night after night because you got the same gear night after night after night. So I don't see any problems with distance. So it's just a matter of how you focus it up, right? If I speak, you're going to hear me however you hear me in the room. If I put a megaphone in front of me where I'm focusing that energy, then it goes a little farther straight out, but it doesn't do anything sideways. So same amount of energy, it's where you just put it. I hope that answers that.
Yeah, thank you, Don. Couple questions about pairs of CP beams, or excuse me, pairs of CP stages in diversity fin. Maybe that kind of gets back to the width, sort of side to side spatial coverage you were sort of mentioning for receive applications.
Well, paddles, D-fins, CP stage, most of these antennas, we were looking at the horizontal coverage because we don't usually have people 40 feet up in the air unless you're doing Cirque du Soleil or something. So we care about the width. So here's kind of here's the easy trick. The normal accepted normal range of human perception for peripheral vision is 120 degrees. If you put your head against a wall and you look straight forward, you would be covering with any of those antennas what you can see until you start moving your eyes or your head, right? So if you hold your eyes straight in front of you, you're probably, from this side to this side seeing about 120 degrees wide. So that's what you're covering. Now, if you were going to use a CP beam, that only has a 70 degree wide pattern. So if you kind of put blinders on, and it's kind of hard to figure out what 70 degrees would be, but that would be the difference, is you're only going to cover, if I do this and look, that's what I'm going to cover. I'm not going to cover this, I can't get on my screen here. I'm not going to cover this stuff I was covering before. So that's kind of important when you get close, because, you can get a big swing in the angle when you're not too terribly far away from it. If you're 100 feet away from the antenna, you got to walk a pretty long distance sideways to get out of the range. So That's what I can tell you about that.
Okay. Let's see. Trying to pick themes here so we can answer multiple at once. Is the CP stage available in white? It is currently not available in white. Compatibility with Shure ULXD wireless. It will be a great
No problem.
partner to your ULXD system.
Mhm.
We do loads of those. Question about location TV and film. As a potential sort of application. I mean, knowing what I know about the location sound world, generally a ruggedized form factor is going to be your friend, just because of the rigors of running around doing wireless and TV film, moving everything around, clanging all your gear around rack boxes and work bins and everything. This thing's perfect for that. You just huck it in there; it's not going to break
Yeah,
on you.
directors have no problem telling you to do something that's impossible and giving you 3 minutes to set it up. So just been
That's
there.
the gig. I'd be terrible at it. That's the gig.
It's just like these people have no understanding of what they're asking, and they ask to do things that are really difficult. And location sound guys are really good at doing the impossible sometimes. But
Yep.
yeah, so I mean, yeah, no problem. I mean, if you were using a paddle, you could. This is basically the same coverage angle that a paddle is. So if you were using a paddle and you switch to this, your coverage is going to be the same essentially.
Yep. Here's one. Using the CP stage in a pair with its 3 dB gain versus two paddles, 6 dB gain at 90 degrees to one another. This kind of gets back to the sort of angle orientation, circular polarization stuff. I don't know if you want to comment on that, Don.
Well, so the you would get about, if we were talking, let's just talk a straight line in front of you, whatever the range you get wherever you are that day with the CP stage, you would get about 20% farther, right? So if you were covering 200 feet with a CP stage, that paddle would do 240 feet probably. Um, if you're down to the last 1 or 2 or 10 feet that your antenna is going to cover for you, you need to change that before you get there. I would never operate that close because too many things, people don't realize that when you stand out, it's turn your wireless mic on, stand someplace and talk and it's going back to the antenna. Move over 6 inches or 2 feet. Your signal could drop 10 dB from nothing. You just moved over 2 feet, and that's just the way things line up sometimes. So when you walk around on a stage with a microphone, or you're walking around with an in-ear, which is the receiver, doesn't matter, same thing. You're in the nice, open, clear main part of that stage. It's easy to get 20 dB shifts in level, right? So we got to always worry about the minimum one. That's why we said at 20, you're good. You could have 40 for 85% of your program. But what are you going to do for the 15% when somebody steps in an RF hole or something? So that's really difficult to predict. That has to do with everything being exactly how it is. Yeah. So you definitely want to have way more than you need because somebody's gonna make you do something stupid and call for it. So be ready.
Richard Stockton, did you have something to say? I thought I saw a raised hand. Richard.
Hey, I'm here. You hear me?
Oh, hey, yes.
Hey, I was helping another customer with the same antenna. So no, I just wanted to tell everyone that don't forget you can use it for receive and transmit. And any questions that come up, just keep asking. after this meeting.
Cool.
Yeah, if you think of something tomorrow, just if you go to our website, there's tech support info is how do you contact us. Just send it on in. Or you can email me. I'm just don@rfvenue.com. You send an email anytime. That's fine.
Great. Well, I know we have a couple more lingering questions, but I think we should probably wrap there, Don. Um, Thank you very much for the presentation. Thanks to you all for attending. Do get in touch with us. CP stages are shipping, so you will find them in the usual places out there in the RF Venue Dealer Distributor Network. Any questions, please feel free to reach out. But thanks again for joining. Really appreciate it. Don, great job as always.
Thanks, guys.